Hello guys and welcome to a new video in physics. In this video we will complete lesson 1. We have here the subject energy. In the equation for work, W equal to half mv final square minus half mv initial square. The quantity half mv square represents a property of the system. This property, which is the ability of an object to produce a change in itself or the world around it is called energy, and its symbol is E. So here we can put a definition for energy. The definition of energy is the ability of an object to produce a change in itself or the world around it, and its symbol is E. The work energy theorem states that when work is done on a system, the result is a change in the system's energy. So W, which is the work, equal to the change in the energy. W equal to delta E. Since work is measured in joules, so energy must also be measured in joules. Through the process of doing work, energy can move between the external world and the system. And here we have an important note. The first one, if the external world does work on the system, then W is positive and the energy of the system increases. The second one is the opposite. If the system does work on the external world, then W is negative and the energy of the system decreases. Kinetic energy. The energy associated with motion is represented by the symbol Ke. This is a definition for kinetic energy. Kinetic energy is the energy associated with motion, and it's represented by the symbol Ke. In the examples we have considered, the object was changing position, and its energy, half mv square, was due to its motion. You can use a bar graph to represent change in energy. This time, the height of the bar represents the amount of work or energy measured in joules. So here we have a ball. This is the first picture. We have it here. A ball was in stop, and after that the ball moved until here. So in the beginning, the kinetic energy for the ball was 0, and because of the movement, so it will have a work. So the kinetic energy before the movement plus the work, it will have a kinetic energy. In the second picture, here we have a ball moving, and after that the ball stops. So in the beginning, it had a kinetic energy, and after that, the work here stopped the ball. So the kinetic energy plus the work, that will equal to kinetic energy 0, because here the ball is stopped. So every object is moving, that means it have a kinetic energy. And if the object is stopped, so it will not have a kinetic energy. Power. The rate at which energy is transformed is power. This is the definition for power. The rate at which energy is transformed. The symbol of power is P, and it's equal to delta E over T. Applying the work energy theorem to this equation indicates that power is also the work done, divided by the time taken to do the work. Power is measured in watts, which symbol is W. 1 watt is 1 joule of energy transferred in 1 second. Now we have a problem. A net force, the magnitude of which is 2800 Newton, accelerates a 1250 kilogram vehicle for 8 seconds. The vehicle travels 80 meters during this time. What power output does this represent? So in the beginning, we can make a sketch for the question. Here we have the force and the displacement in the same direction. So we should write the noun and the unknown for the question. The noun for the question, here we have 2800 Newton, which is represent the force. And after that, we have 1250 kilogram, which is represent the mass of the car. For 8 seconds, that represent the time. The vehicle travels 80 meter. 80 meter, that represent the displacement. What power output does this represent? So the unknown, or we need to calculate the power from this question. We know that we have a law which is P equal to W over T. W, or we can say P equal to E over T, it's the same, because we said that energy is equal to the work. And here, because that we knew that the work is equal to FD cosine theta, so we can write our law just like this: P equal to FD cosine theta over T. F, we have it in the question, which is 2800 Newton, multiplied by D, which is the displacement. We have it in the question, which is 80 meter, multiplied by cosine theta. Here we have the force and the displacement in the same direction, so the angle, it will be 0, so cosine 0, that's equal to 1, over T, the time is equal to 7 seconds. The final result should be 28,000 watt. 28,000 watt. We can write it as this, or also we can write it as 28 kilowatt. When force and displacement are in the same direction, P equal to FD over T. However, the ratio D over T is the speed, so you can also use P equal to FV. That means when we have the law for the power, which is P equal to the work over T, and we said that the work equal to F d cosine theta over T. If the angle was 0, so the cosine theta for the angle 0, it should be 1. So our law will be P equal to F d over T. Now we already knew that d over T, that represent the velocity. So we can write our law P equal to F V. And this is another law for the power. We can calculate the power from this law, which is P equal to with the work divided by the T, which is the time, or we can find the power in this law, which is P equal to F V, or also we can find the power in this law, P equal to delta E over T. This is 3 laws for the power. Now we have example problem 2 in the book. A sailor pulls a boat a distance of 30 meters along a dock using a rope that makes a 25 degree angle with the horizontal. How much work does the rope do on the boat if its tension is 255 Newton? In the beginning, we will write the noun and the unknown for the question. The noun that we have in the question, we have the distance, which is equal to 30 meter. The displacement, d equal to 30 meter. And also we have the angle here, which is represent theta equal to 25 degree. And we have also the force F equal to 255 Newton. How much work does the rope do on the boat if its tension is? So we need to calculate the work, which is W. We have a law, W equal to FD cosine theta. F, we have it in the question, which is 255 multiplied by 30 meter multiplied by cosine of 25. So by using the calculator, the final result will be 6.93 times 10 to power 3 joule. This is the final result for the work. Now for practice problems in the book, we have question number 5. If the sailor in example problem 2 pulls with the same force through the same displacement, but at an angle of 50 degree, how much work is done on the boat by the rope? So by using the same numbers and the same law, which is W equal to F d cosine theta. So W will equal to F 255 multiplied by D, which is 30 multiplied by the cosine theta for 50 degree, which is approximately 0.6. The final result for the work will equal to 4,590 joule. This is question number 5. Now about question number 6. Question number 6 is exactly the same for question number 5. So here we have the distance, and also we have the angle and the force. So we will exactly do the same for the question number 5 or the example problem. Just we will write the law, which is W equal to F d cosine theta, and after that write the numbers and find the result, which is the W, which is the work. So we will go to another question.